All right, guys, welcome back. Here we go again. Try this problem, see what you can come up with, pause the video, and come back when you're done. I'm going to factor out a cosecant x. I get cosecant x minus 5 equals 0. Set this equal to 0, set this equal to 0. I have cosecant x equals 0, and cosecant x minus 5 equals 0. Isolating the trig function, I get cosecant x equals 5. So now coming back to the left-hand side, just a quick reminder, anytime you have tangent x or cotangent x equal to 1 or negative 1, for these types of problems, you're going to use your triangles, your 45, 45, 90 triangles, and you'll be able to solve them. But any of the other trig functions equaling 0, 1, or negative 1, you're going to want to switch to sine and cosine, and you're going to want to switch to curves. So cosecant x, I know is 1 over sine x, that equals 0. I'm going to multiply both sides by sine x. That gives me 1 equals 0, which, no it doesn't. 1 doesn't equal 0, so I'm going to disregard the left side of this equation. Now on the right-hand side of the equation, I have cosecant x equals 5. That's 5 over 1. Cosecant is hypotenuse over opposite, and so I wonder, is it possible for a triangle to have a hypotenuse of 5 and an opposite of 1? Again, a hypotenuse of 5 with an opposite of 1. Yeah, it's perfectly possible. It's not one of our normal triangles, but it is possible. And so I am trying to figure out now, what is this angle? What is the answer for this equation? So if I have cosecant x equals 5, and if it's not one of my normal 30, 60, 90, 45, 45, 90 triangles, then I'm going to just do my best to get this thing to be calculator ready. So calculators don't have a cosecant or a cosecant inverse button, so I'm going to switch it to sine. I have 1 over sine x equals 5. Get sine to the top, so I have sine x equals 1 over 5. And then solving for x, I'm going to hit both sides with a sine inverse, and I end up with x equals sine inverse of 1/5. Now, knowing that sine inverse of 1/5 can only have one answer, looking at the situation that I have, there's two different possibilities. There's the one on the right and the one on the left. Sine inverse of 1/5 is going to be, technically speaking, the one on the right, because the angle on the right has the smallest absolute value. So sine inverse of 1/5 is what the angle on the right is, and based off of this angle, we'll be spinning in full circle. So I have sine inverse of 1/5 plus 2 pi n. Now this other angle, I'll switch to green here, this second angle, getting a name for that angle is a little bit more tricky, because it's not a matter of spinning in a half circle, it's not a matter of spinning in a full circle, it's kind of off there on the left, and we don't necessarily know what to call it right off the bat. But if I know that sine inverse of 1/2 is, again, this positive guy here, then if I felt like switching it, if I took the negative of it, this little pink guy would be negative sine inverse of 1/5. And now the pink angle is not an answer, but if I add 180 to it, that gives me the answer that I was looking for. So the second answer for this particular equation is negative sine inverse of 1/5 plus pi. That gives us the green angle that we originally had. And then we're going to spin in full circles, plus 2 pi n. This negative sine inverse 1/5 plus pi, oftentimes it will be written reversed. You would have pi minus sine inverse of 1/5 plus 2 pi n. But either one of these are perfectly fine. They're both perfectly acceptable. And so this set of answers here is the final version, the final answer for this equation. Now there is another version of this answer. It's not something you would necessarily have to come up with on your own, but if you saw it as an answer, I didn't want you to think that your answer was wrong. I just kind of want you to see it so you would understand maybe where it came from. So let me get back to where we just were. If we had, say, cosecant x equals 5, again, that's 5 over 1. setting up our triangles. We've got 1, 5, we've got 1, 5, and we know that this angle here is what we call sine inverse of 1/5. So this different style of answer, instead of doing what we did above, which is just to flip the sine inverse of 1/5, and then they call it negative sine inverse of 1/5, they actually redraw the triangle. So they would give it an opposite of -1, a hypotenuse of 5. It's still the flipped version of the triangle above it, but instead they're going to actually find that sine of x equals opposite over hypotenuse, and then they get the x all by itself by saying sine inverse of -1/5. So look at the difference here. Sine inverse of -1/5 is the same angle as negative sine inverse of +1/5. You can't just pull the negative out of the argument there. You can't just pull that negative out. That's bad. Don't do that. But they are the same angle. And so from here, they would say sine inverse of -1/5. They would then add 180 degrees. So it's sine inverse of -1/5 plus pi. And now that they've gotten over to the actual angle that is the answer, they would simply add 2 pi n to go in full circles. So if you saw this version with a -1/5, instead of, say, a negative sine inverse of +1/5, it's actually the same answer. It's just a bit different looking. All right, I hope that made sense.